Today's topic is counting rules, permutations, and combinations. We're going to start out with the fundamental counting rule. The fundamental counting rule says this: if one event can occur in n ways and a second event can occur in m ways, then the number of ways the two events can occur together is n times m ways. For example, if you have 5 shirts and 4 pairs of pants, in how many ways can you have 1 shirt and 1 pair of pants at the same time? We can see that in this diagram. In another example, if you have a combination lock with 3 numbers and each of the possible 3-digit choices have 10 possible numbers, 0 through 9. Then you have 10 for the first number, 10 options for the second number, and 10 for the third. The total number of ways this can happen is 10 times 10 times 10, or 1,000. Some questions in this section require the use of factorials. You can find the factorial key on your calculator by looking for the exclamation mark. You might see this as X exclamation mark or N exclamation mark. Or it might be embedded in the calculator under a key that says PRB, or in other calculators, a key that says math. Even without your calculator, you can compute factorials easily for small numbers. The factorial notation denotes a product which starts with the number that's given and then multiplied to each successive natural number in decreasing order all the way down to 1. 0 factorial is defined as 1, and 1 factorial is also 1. Thus, 3 factorial is 3 times 2 times 1, or 6, or 4 factorial is 4 times 3 times 2 times 1, or 24, or 5 factorial is 5 times 4 times 3 times 2 times 1, or 120. For example, if you have a collection of n different items, they may be arranged in order of n factorial ways. So if 4 cars want to park in the parking lot in the first 4 front row spaces, then the number of ways this can happen is 4 factorial, or 24. Why? Because 4 different cars can park in the first space, then there are 3 left over for the second space, 2 cars left over for the third, and only 1 left over for the last spot. Thus, you have 4 times 3 times 2 times 1, or 24. Another example is called the traveling salesman problem, which may be used for questions in which you have to figure out how many routes are possible. If you have to travel to 6 different cities for work, New York, Dallas, San Francisco, Miami, Los Angeles, and Denver, how many different routes are possible? You can see this as 6 factorial, or 720. There are whole segments of business that deal with logistics or supply chain management. In these examples, they're looking for the most efficient way to take, for example, 100 packages to 80 different destinations. With time, gas, wear and tear on the vehicle, the question is, which route is best? This rests on the routes, overlap, and efficiency. So if we have 50 countries that we can visit, but we will only visit 4, the calculation looks like the following. We have 50 factorial over 46 factorial, or 5,527,200. Finally, we're going to discuss permutations and combinations. In these examples, we're also looking in how many ways a certain event will happen. We use permutations when order matters. However, when we want a group, but it doesn't matter in which order they're arranged, we use combinations. The formulas for permutations and combinations are very similar. We use P for permutations and C for combinations. There are keys on your calculator to compute each. The requirements for permutations are: there are n different possible items. We select the items R taken from the n items without replacement in the group. We want to know all of the arrangements of the items in different sequences. For example, ABC is not the same as CBA. Generally, we use permutations for a race, contest, election, or a specific leadership position. The rank or order makes a difference. For example, if we have 20 people entered into a contest in which there's a first prize and a second prize, then the calculation is PNR, or P22, or 380. The requirements for combinations are as follows. There are n different possible items. We select some number of items R taken from n items without replacing them in the group. We consider all arrangements of the items to be the same. For example, ABC is the same as CBA, generally when order doesn't matter. For example, if we want to find the number of different possible 5-card poker hands, we evaluate this by computing C525. Note that the order of the cards in your poker hand does not matter. Or how many ways can a dealer draw 2 cards for a blackjack game? This would be 52 cards taken 2 at a time. Notice that the order does not matter here either. Lastly, in the California Fantasy 5 lottery, You have 39 numbers, and you're going to choose 5. First thing you do is you ask, does order matter? It doesn't matter. So you're going to just choose 5 numbers. We use combinations, the combination of 39 things taken 5 at a time, or 575,757. This video presents various ways in which you can count the number of ways an event will happen. This is Rachel Winston, and I hope you have a great day.